If you've been learning AWS and wondering what it actually looks like to operate infrastructure in the cloud, not just build it, but keep it running, secure, and scalable, this video is for you. I'm going to break down AWS cloud operations from the ground up, what the role looks like, what the certification covers, and the core services you need to master. Let's get into it. Here's what we're covering today. First, we'll define what system operations actually means, the real responsibilities. Then we'll look at the AWS SysOps certification structure so you know what to expect. After that, we'll dive into the 5 core AWS services: networking with VPC, compute with EC2, storage with the S3 and EBS, and identity and access management with IAM. And we'll wrap up with the IAM best practices that every cloud professional needs to know. So let's start with the basics. What is systems operations? It's everything you do to keep a system up and running. Build it, test it, deploy it, monitor it. Maintain it, secure it, that's the life cycle. You build the infrastructure, you make sure it works correctly with no security holes or performance issues, you deploy it, and then, and this is where the real job begins, you monitor it continuously and fix things when they break. Think of it as a cycle: build, test, deploy, monitor, maintain, secure. And you just don't do it once, it's ongoing. Security isn't a one time setup, it's a continuous responsibility. Monitoring isn't optional, it's how you catch problems before your users do. This is what separates someone who can spin up an EC2 instance from someone who can actually run production infrastructure. Now, here's the thing: a lot of these operations shouldn't be done manually. Automation is a massive part of modern cloud operations. Think about it. If you deployed a huge infrastructure in US East for a bank, and now you need the exact same setup in US West, are you going to manually recreate hundreds of EC2 instances, security groups, and configurations? That's not just tedious, it's prone to mistakes. But if the system was deployed as a script, CloudFormation, Terraform, shell scripts, whatever tool you prefer, you can run that same script in a new region and get the exact copy, same configs, same security, zero human error. Automation gives you 3 big things. First, repeatable deployment. You can spin up identical environments on demand. Second, self-describing systems. Your infrastructure is defined in code, so anyone can read the template and understand what's deployed. And third, consistent test environments. You can create an exact copy of production to test bug fixes without risking the live system. We'll get deeper into CloudFormation and infrastructure as code later, but to know this is fundamental to operations. Now let's talk about the core services. There are really 5 pillars you need to understand: networking, compute, storage, databases, and access management. These are the building blocks of everything in AWS. Let's walk through each one. First up, networking, which starts with VPC, Virtual Private Cloud. When you create an AWS account, you need to carve out your own piece of network. That's what a VPC is. You're creating boundaries saying, everything I deploy will live inside this isolated network. The whole point is logical isolation. Your traffic stays within your network and nobody from the outside can access it unless you explicitly allow it. Inside your VPC, you configure the IP address range using CIDR notation. You set up routing, public subnets, private subnets, and gateways. You define your security settings within NACLs and security groups, which are essentially your firewalls controlling which traffic can come in and what gets blocked. And here's an important concept. VPC is a regional construct. If you create a VPC, it exists in one AWS region. You can't have a VPC that spans US East and US West. You'd create separate VPCs for each region. Before we go further, let's talk about how AWS infrastructure is organized. This is critical for understanding where your resources can actually live. AWS has regions all over the world: US East, US West, Europe, Asia, Pacific, and more. Within each region, there are multiple availability zones, which are essentially separate data centers. The idea is redundancy. If one AZ fails, your application can fail to another. So you have 3 levels: availability zones inside regions, and all regions together make up the global infrastructure. Now, here's what you need to know. Different AWS services have different scopes. AZ scope services like EC2 instances, EBS volumes, and subnets are stuck in one availability zone. Regional services like VPC, S3, AMIs, and EBS snapshots work across all AZs in a region, and global services like IAM, Route 53, and CloudFront work everywhere. When you deploy an EC2 instance, you pick a specific AZ. When you create an S3 bucket, you only pick a region. AWS automatically replicates your data across multiple AZs for durability. Quick but important concept: service limits. AWS puts soft limits on many services, like a cap of 50 EC2 instances in a new region. These can be increased by contacting AWS support. Then there are hard limits, physical or system level constraints that can't be changed, like bandwidth caps on network interfaces or API throttling limits on services like SNS. If your system is getting throttled, always check: is it a soft limit you can raise or a hard limit you need to architect around? Let's move to compute. This is where your applications actually run. EC2, Elastic Compute Cloud. It's a pure compute service. When you launch an instance, you start with an AMI and an Amazon machine image. These are pre-configured operating system images: Amazon Linux, Ubuntu, Red Hat, Windows. AWS provides free ones, and there are marketplace AMIs for specialized software. But here's where it gets powerful: you can create your own AMIs, configure an instance exactly how you need it, install your web server, your application, your dependencies, then capture that as a custom AMI. Now you can launch thousands of identical copies on demand. EC2 is highly scalable. Start with what you need: 10 instances for a new application, and scale to hundreds or thousands as demand grows. And it's not one size fits all. AWS offers hundreds of instance types organized into families: compute optimized for CPU heavy workloads, memory optimized for databases, GPU instances for machine learning and graphics, storage optimized for data intensive applications. You pick the instant type that matches your use case so you're not wasting resources or money. Now let's talk about what is arguably the most important service in all of AWS: IAM, Identity and Access Management. This is the very first service you use when you create an AWS account, and it touches everything. IAM handles two things: authentication and authorization. Authentication handles answers who are you, usernames, passwords, MFA tokens, certificates. Authorization answers what can you do, which resources you can access, and what actions you can perform. Not everyone in a company should have the same access. An admin needs broad permissions, but a developer only needs access to developer environments. This is a principle of least privilege. Gives people exactly the access they need to do their job, nothing more. There are two ways to access AWS resources: console access, that's a web based management console where you log in with a username and password, and programmatic access, using the CLI, SDKs, or APIs, where you authenticate with access keys and secret keys. You don't use username and passwords for programmatic access for security reasons. And for console access, you should always enable multi factor authentication, MFA, that second layer of verification using an authenticator app or hardware token. Let's map out the security credentials. The root user, created when you first set up your account, has unlimited power. That's why you lock it away and create a separate admin user for daily work. Then you have IAM usernames and passwords for console access keys for programmatic access, MFA for the additional authentication layer, and key pairs for SSH access to EC2 instances. Each serves a specific purpose in the security chain. IAM uses policies, JSON documents, to define authorization. There are four types: identity-based policies attached to users, groups, or roles and define what identity can do. Resource-based policies attached to a resource like an S3 bucket and define who can access it. Service control policies are pushed from an AWS organization to all member accounts, setting guardrails across the entire company. And ACLs, access control lists, are simpler restrictions that don't use JSON, like network ACLs on your VPC. Here's what the policy actually looks like. This one says, allow all EC2 actions on all EC2 resources, but only if multi-factor authentication is enabled and the request comes from a specific IP address. See how granular this gets? You control the effect, allow or deny, the actions, what operations are permitted, the resources, which specific assets, and conditions, additional requirements that must be met. This level of control is what makes IAM so powerful. Now, IAM roles. Unlike users who have permanent access, roles provide temporary access. Think of a scenario. An external auditor needs to review your infrastructure for compliance. Instead of creating a permanent user account, you create a role with the right permissions. The auditor assumes the role, does their work, and when they're done, the role is relinquished and access is gone. Roles are also how services access other services. An EC2 instance that needs to write to an S3 bucket assumes a role to get that permission temporarily. Roles are also how you handle cross-account access. Say you're a developer with access to the dev account, and you need to deploy code to production, which is a separate AWS account. Instead of creating a second user in the production account, you assume a role that grants temporary production access. You make your changes, relinquish the role, and you're back to your normal dev permissions. Clean, auditable, and secure. Let's wrap up IAM with the best practices every cloud professional should follow. First, never use root credentials for daily admin work. Create a separate admin user and lock root away. Second, follow the principle of least privilege. Only grant access the people need. Third, use IAM roles for cross-account access instead of creating duplicate users. And fourth, enable MFA on all admin accounts. That extra layer of security is a non-negotiable. Let's recap the key takeaways. System operations is a full lifecycle. Build, test, deploy, monitor, maintain, secure. Automation through infrastructure as code eliminates human error and enables repeatable deployments. AWS core services, VPC, EC2, S3, and IAM are the foundation of everything. IAM roles provide temporary auditable access for users and services, and the principle of least privilege should guide every access decision you make. In the next video, we'll go deeper into compute, EC2 instance types, auto-scaling, and how to right-size your infrastructure. We'll also start getting hands-on with labs. If you found this helpful, subscribe and hit the bell so you don't miss it. Thanks for watching. If you're studying for the AWS SysOps Associate Certification or just want to understand cloud operations better, this series will walk you through everything. Drop a comment if you have questions, and I'll see you in the next one.